we are going to be looking at reading and interpreting scales. So we use scales a lot in everyday life, probably more than you think. They can be used to measure weight, height, capacity, so if you're measuring any liquids, temperature and speed. So it's not just in the classroom where we use measurements to measure with our rulers or with our protractors. We use scales in the kitchen, we're measuring out ingredients. The car is always measuring the speed that you are travelling at. So when reading scales, it is really important to work out what the scale is going up in to be able to read it correctly. So we're going to jump straight into some examples. Write down the number the arrow is pointing to in each of the following scales. So to be able to do this, you have to work out what each small part is going up in. They're called increments. So what each little increment is going up in here to be able to figure out what the arrow is pointing to. So you can see it's got 500, 600, 700. Now some people like to work out the middle where there's a longer line here. So the middle of 500 and 600 is 550. But from 500 to 600, if you count, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 little parts there in between the 500 and the 600. So what you do, there's 100 in between there. So 100 divided by the little 10 parts gives you 10. So we know we're going up in tens here. So it goes 500, 510, 520, 530, 540, 550. And that's your check almost. So to go all the way up to the arrow, 560, 570. So the arrow is pointing at 580 grams. Part B then, so we've got 6, 7, 8. So we can see they are going up in ones. And again, we've got 10 little increments between the 6 and the 7. So some people, like I said, like to figure out the middle one, so they know roughly what's halfway. It'll help them work out the small parts. So from 6 to 7 is 1. So in between 6 and 7, we know we have 6.5. So this long line here is 6.5. So for every 1, we've got 10 little parts. So 1 divided by 10. If we think of our place value chart, going from our units to the right, we go down to our tenths. It gives us 0.1. So we're going up in 0.1s. So for our 7 here, we have 7.1, 7.2 for the arrow. Part C then, so we've got 300 to 400 and we want to work out what the arrow is pointing at. So again, work out how many increments you've got. So 1, 2, 3, 4, 5. So between 100 we have 5 spaces. So 100 divided by 5, so we know 10 5s are 50, so 20 5s in 100. So our scale here is going up in 20s. So we have 320, 340, 360, 380, 400. It's worth checking sometimes. So like we said, our arrow is at 320, 340. And finally, so we have 10 to 20, and our arrow is here. So we've got less increments here, so we've only got 1, 2, 3, 4 in a space of 10. So we can either do 10 divided by 4, or lots of people here like to find the halfway. They find it easier to find the halfway, which we know is 15. And then they like to find the middle of 10 and 15. And the middle of 10 and 15 is 12.5. If you do it this way, 10 divided by 4 gives you 2.5. So you know you're going up in 2.5. So it goes 12.5, 15, 17.5, 20. Now we're going to have a look at some GCSE questions where they use scale. So question 1, part A, how much does the toy car weigh? So you can see the toy car is on a weighing scales here, and then we just need to put the measurement. So again, you need to work out the scale first before you start. So you can see from this 0 to 100, let's count how many little spaces there are. So 1, 2, 3, 4, 5. So in the space of 0 to 100, there's 5 spaces. So 100, divided by 5 is 20. So this scale is going up in 20s. So if we go closer to our arrow, so here's our 400, so we've got 420, 440. So the toy car weighs 440 grams. Part B, the car is put on a different scale. Draw the pointer to show the car's weight. So we know the car weighs 440 grams. But we need to check this scale now to make sure we put the arrow at the correct place. So from 300 to 400, we know that's 100. If we count how many spaces, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in 100, there are 10 spaces. So if we divide it by 10, 100 divided by 10 is 10. So we're going up in tens here. So here's my 400. If we're going up in tens, 410, 420, 430, 440. And put an arrow nice and clearly towards that 440 grams. Part C, how much heavier is the toy bus than the toy van? So first of all, we're going to have to work out the weight of the toy van and the toy bus, and then how much heavier, subtract the two. So if we work out what it's going up in first, again work out how many little parts there are within the 100. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So because there's 10 parts in 100, 100 divided by 10 again, we know we're going up in tens. So we've got 310, 20, 30, 40, 50, 60, 70, 80. So the van is 380 grams. Now check the scale here. We're working on a different scale here for the bus. So notice it's got 500 grams and 1 kilogram. Remember, 1 kilogram is the same as 1,000 grams. That's something that you need to know. Now, like I said, lots of people will find it easier to work out the middle here to save us counting all of these parts going across. So the middle of 500 and 1,000 is 750. So we know this middle marker here is 750 grams. Now, if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So between 500 and 750, we have 10 little spaces. So we know the space between 500 and 750 is 250. And if we divide it by 10, it's telling us our scale is going up in 25s. So you can check if you want to. So 500, 525, 550, 575, 600, 625, 650, 675, 700, 725, 750. So it works. So like we said, it goes 25, 50, 75, 600, 625, 650. So the bus is 650 grams. Now remember, it did ask how much heavier is the toy bus than the toy van. So 650 grams and 380 grams, and we want to subtract the two. So I'm going to do a little subtraction. Bigger number on the top, so the bus value on the top, 380 underneath, and subtract. So 0 take away 0 is 0, 5 take away 8, remember we need to borrow, 15 take away 8 is 7, 5 take away 3 is 2. So the bus is 270 grams heavier than the toy van. Question 2 then. So part A, the diagram shows an empty measuring cylinder with markings in millilitres. So this is the type of cylinder that we would use to measure liquids, so water for example. So 320 millilitres of water are poured into the cylinder. Draw a line on the cylinder to show the water level. So before you can just find 320, we need to work out what's going up in again. So if we start at the bottom, we know this line here is 100. So if we count how many parts are in between, we can work out what it's going up in. So 1, 2, 3, 4, 5. So there's 5 increments, 5 parts to get to 100. So 100 divided by 5, and I know we've had this a few times now, is 20. Very popular scale that they use. So we want to draw the line of 320 millilitres onto the cylinder. So here's our 300. We know it's going up in 20s. So this line here is 320. So just draw a straight line going across on the cylinder at 320. Part B, a very small jug is filled with water. The water is then poured into an empty measuring cylinder. This process is carried out a total of 6 times. The final water level is shown in the diagram here. How much water does the jug hold? So first of all, again, check the scale is the same, and we can see it is. There's 1, 2, 3, 4, 5 to get to 100. So we know we're still going up in 20s. So if we work out what the level of water is at, so here's my 400, 420, 440, 460, 480 millilitres. So the cylinder is at 480 millilitres. It said it poured water from a small jug 6 times, and we want to work out how much water the jug holds. And it was empty at the start, so we don't have to worry about that there was some there first of all. This whole 480 millilitres of water has come from 6 jugs of water. So to find out what one jug holds, we want to divide. So we want to do 480 divided by 6. Now we can do this either in a bus stop, or you can do it in your heads, because we know 48 divided by 6, 6 eighths are 48. So 48 divided by 6 is 8, and then don't forget to keep that 0 on the end. So each jug is 80 millilitres. Part C. The water in the cylinder on the left is to be poured into the cylinder on the right, which already has some water in it. So this time the cylinder is not empty. We already have some water in it first of all. Draw a line on the right hand cylinder to show the new water level. So if we have a look at this one, this is the same scale as what we were using before, so we know we're going up in 20s. So the line is at the 480 millilitres as it was in part B. But this cylinder is a different size, so check the scale. So this time we've got 1, 2, 3, 4, 5 parts to make 200. So we need to do 200 divided by 5. Well, 5 goes into 20 4 times, and put that 0 on the end. So this time we're going up in 40s, not 20s. Okay, so the level of water is already here. So we first of all need to work out what it's on. So remember, we're going up in 40s. So we've got 200, 240, 280, 320, 360. So this cylinder already has 360 millilitres of water in it. And we want to put another 480 on top of this. So we want to add these two values together. So we have 360 add 480. So 0 add 0 is 0. 6 add 8 is 14. So 4 carry the 1. 3 add 4 add 1 gives you 8. So you have 840 millilitres. So like it says, you need to draw a line on this cylinder to show the new water level. So we need to find 840. Remember, we are going up in 40s. So here's our 800. So straight away, 840 is this first line after the 800 here. So you draw your line here. Question 3. The speedometer shows the speed a car is travelling on a road. The car joins a motorway and its speed increases by 25 miles per hour. What speed is the car travelling on the motorway? So first of all, we want to read what this arrow is pointing at on the scale, on the speedometer. So again, we need to work out what it's going up in. So we can see we're going up in 20s here. So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 little parts again to get to 20. So 20 divided by the 10 gives us 2. So we're going up in 2s on the speedometer. So here's our 20, so 22, 4, 6, 8, 30, 32, 34. So the scale is showing 34 miles per hour. Like it said then, the speed now increases by 25 miles per hour. So if it increases, we've got to add on another 25. So we've got 34, add 25. Well, 30 add 20 is 50, 4 add 5 is 9. So 59 miles per hour. And last example then, so example 4, a box is placed on a scale. 8 identical blocks are then placed in the box. So you can see on this scale, you've just got the box and you've got a measurement for it. And then on this scale, you've got the box and the 8 identical blocks. And it's asking us find how much one block weighs. So the first thing you have to do is find out the weight of the box before any of the blocks got put in. So again, work out your scale first. So we've got 1, 2, 3, 4, 5 again to get to 100. 100 divided by 5 gives us 20. So we're going up in 20s. So the scale is going to point at, here's your 200, 220, 240. So your arrow here is pointing at 240 grams. Now if we work out the weight of this weighing scales here now, so this is the box and the 8 blocks. So it's the same scale, 1, 2, 3, 4, 5 and 100. So we know we're still going up in 20s. So if we jump all the way over to here, so 900, 920, 940, 960. So the box on its own weighs 240 grams. The box and the blocks weighs 960. So the first thing you want to do is take away the weight of the box. So we want to do 960 take away 240. So 960 take away 240. If we do a little take away sum, 0 take away 0 is 0, 6 take away 4 is 2, 9 take away 2 is 7. So we have 720 grams left. So if we've taken away the weight of the box, that means the 8 blocks that are left over weigh 720 grams. We want to find out what one block weighs. So if we know 8 weighs 720, to find 1 we want to divide by 8. So one block is going to be 720 divided by 8. You can either do a bus stop, or you might have spotted that 8 does fit into 72. So 8 goes into 72 9 times, and don't forget that 0 on the end. So each block weighs 90 grams.